back again with the B and K in the schematic. And as usual, in my haste to get to the good parts, I completely forgot to mention a number of things that are pretty important. One is, you really should study the information that's right over here. It tells you what all the connections are for the two switches, the function switch and the off-on life test switch. Now, those switches are function switch. It's not labeled as such here, but that's what that one is. And the off-on life test switch, which is there. Now, why is that important? Well, for example, if you look here, you see that in the off-on life test switch, when it is off, the connections E and F are made. Well, E and F, it turns out, are right there across the meter. So you know that when the switch is in the off position, the meter is shorted. So it can't read anything. That's also to help the meter survive shocks in moving it around and things like that. Similarly, when the switch is in the on position, A is connected to C. Well, that's actually already obvious from up here, the on position. In the life test position, A is connected to B. Once again, obvious from this. What's not obvious are some of these other connections. For example, over here you see a switch where pin 11 connects between 9 and 10. If you want to know what positions they're in, first you have to read this. The test switch in test position 1. In other words, that's the way this schematic is done. Then, in test position 1, if you want to know 9 and 10 or 10 and 11, well, right up here, you see it says that when you're in the short gas position, 10 is connected to 11. When you're in the test 1 position, 9 is connected to 11. That's this symbol here. And then there are a number of other switches that you need to be able to understand. There's a 1, 2, 3, 4, 5, 6, and then a whole slew of them down here. So be sure that you read and refer to this information when you're trying to figure out the schematic. Next thing is, I showed you how the basic circuit works and how the bridge here varies the signal voltage to try to keep up with power line variations. So let's take a look at that. I'm going to turn the tester on. We set the heater to the right position. We've plugged the tube into the proper socket. We let it warm up. We leave this switch in the shorts position, and we look to see if there are any shorts, and there aren't any. We look at the meter. If there were grid emission, the meter would show that grid emission, and it doesn't. So we're ready to do the next test, which is to move this to position 1. Now when we do that, what we're essentially doing is we are connecting GM1 to that center tap, which eventually comes back to that number 83 rectifier. So in other words, we're connecting it into the mutual conductance circuit. Now I'm going to advance the sensitivity control. The sensitivity control is essentially the volume control for the meter. It's right there. Right now it's set at the bottom, or in other words, it's shorting the meter out or providing very low resistance across the meter. So let's start raising it up. And what we're going to do in test 1 is we're going to raise it until it just tests good. Very bottom there. And we'll look at it. Well, it's reading about 84. It's supposed to read 76, but as I told you in an earlier video, this tester isn't calibrated yet. Now let's go to test 2. I always like to turn sensitivity down to 0 before I switch this. You don't have to, but it's just a good idea. The reason is that the meter could peg, and I just don't like to see meters slammed around like that. So up we go, once again, looking for the very bottom of the good range. And here it's about 60 or 61. It should be 56. Once again, that's pretty close. So that 6U8 is at least close to being a good tube, although maybe marginal, but we'll find that out after we calibrate. So what have we done? Well, we've provided all the signals you need here. We connected the cathode to ground. In test 1 position, we tested one side of this tube. In the test 2 position, we tested the other side of the tube. You'll notice there are 2 plate connections, pin 6 and pin 1. There's a grid 1 and grid 2 for the left side and a grid 3. And there's a grid for the right side, just G, pin 9. Those are the signals. Cathode to ground, heater to the heater, bias to the grid, screen voltage to the screen grid, GM to the plate. Now, if you're testing tubes that don't have grids, in other words, tubes that do not have mutual conductance, but just have emission, like rectifiers or diodes, then you use an AC voltage. At the very top, you see 200 volts are used for high voltage rectifiers. For lower voltage rectifiers, you use 35 volts. Test 1 is rectifier 1, test 2 is rectifier 2. 30 volts or 35 volts AC. If you're testing a diode, in position 2 and position 3, you use 35 volts also. Now, why is it position 2 and position 3? Because most of the tubes that have diodes in them that are not rectifiers are detector amplifier tubes, where one side, like the 6U8, will be a triode. But there will also be, in place of the pentode in this one, there will be a pair of plates that are used for the detector. In that, those two are used as diode 1 and diode 2. In other words, test 1 for those tubes, this position, is for the amplifier. Test 2 is for one of the diodes, and test 3 is for the other diode. Now, this tube doesn't have a test 3, so it just, meter goes to 0. In the next video, we'll talk a little bit more about what can go wrong and what the symptoms are in this circuit.